We are switching from strategy to action to see how AI is actually keeping our networks reliable, fast, and ready for anything.
Tamás Bicsak from Telekom will take us inside one of the most complex environments on Earth, TelCo networks, and show us how AI-driven agents help keep them running like clockwork.
So let's see what happens when machine learning meets telco. Please welcome Tamás Bicsak.
Thank you very much, and good to be back as well. Like Gergely said, it's a special place for me as well, spending here, not necessarily just here, but 17 years at Nokia. So it's really a good, let's say, way to come back. And I was answering to Adi's call to, okay, let's present something what we do in terms of AI. I will be a bit more practical, so my presentation will be about telecommunication in principle, that how we are using AI and different AI technologies for telco operation. But before going into that, just showing, so I'm working for Deutsche Telekom, the headquarter, but in principle, okay, I believe many of you know at least Magyar Telekom here, but also Deutsche Telekom is a leading telco brand worldwide. It's basically the T-Mobile US, the Deutsche Telekom in Germany. I'm talking segment by segment, and we have 9 netcos in Europe. We are also, and we call it unmatched network leaders, so leading especially in 5G, both in the US as well as in Europe. Our combined customer number is 300 million in the US and in Europe, so this is a quite big number, I would say. And definitely we are one of the, let's say, strongest brand, be it as well as in principle as a marketing brand, as well as a brand which is able to provide consistent and strong customer experience to our customers. Going to what TDI is, so you could see on the first slide that yes, I'm from TDI, but what does TDI mean? So it's called Technology Delivery International. This is like a centralized service delivery organization for all of the national operators in Europe. So you can see all of those magenta countries. So in principle, we have 9 countries in the European segment, and we have a Germany, which is always treated a bit specific. But in general, the point is that we are working in this centralized delivery organization who are developing as well as delivering the different technologies, both in access, core, cloud, transport, devices, and of course, automation. Why I'm telling this? Because the use cases what I'm going to show, those are spanning different domains. And that is important for us to understand as well, that whenever we are talking about telco operation, it is covering all kinds of technologies. So in order to have a simple phone call, you have tremendous amount of technology inside, be it from the device to the access side, to the transport, to the core network, and so on. So in principle, this is a very, very complex technology. But going into the first use case, actually we showcased in the MWC as well. So you can see the booth that we had in Barcelona this year, which is specific to the, we call it Run Guardian agent. And this is a true multi-agent use case. But okay, what is the problem statement? So whenever we are talking about different access site or cell site, the performance degradation is not easy to detect. So for those who are not from Telekom, so in each and every region, we have different sites, radio sites, which is covering a certain geographical area. In the cities, even some segments of the streets. So it's a very, let's say, it's like a cluster of different cells which are covering. Of course, if you move more and more people into the same site, then you would have performance degradation because in general, you are moving many users into the same site. Therefore, your network performance can go down. But of course, at the moment, how we are doing before the agentic AI use case, that we see in the performance monitoring that yes, we have a degradation, then an engineer is going there as a reactive approach, tuning some parameters, and based on that, we might be able to solve the issue or not. But of course, our objective is to do it proactively, not just reacting what we have on the performance dashboards. So what we want to do is that we monitor the network in near real time to see that, okay, where are the possible degradation, then prioritize that, okay, what are the effects of this degradation, and recommend or even autonomously implement some of the changes that is being reported or recommended. And of course, we want to have higher customer satisfaction and then go with that. What is our solution? So our solution is a multi-agentic approach. Actually, we have 3 agents in this solution. And by the way, this is already in production in Germany. So this is not something which is, let's say, a use case just for the labs, but this is already in production. So we have a so-called people event agent, which is scanning through all of the public website on different events for the next 90 days. Basically, concert, sport events, any marches, whatever. So basically, whatever is, we already know that we can prepare for it. And then this agent is able to provide insight and information to the next agent, which is this monitoring agent, which is constantly monitoring that how the system is actually behaving. Whenever this monitoring agent is get the necessary data, as well as it gets the actual information that yes, there is some degradation or the performance is changing, then it's able to actually recommend issues, and then it is actually going to the third agent, which is called the remediation agent, which will get from so basically the middle one is providing the insight and the recommendation, and the third one is the one which is actually executes on those recommendations. And basically, there are two ways to do that. One is that it's fully autonomous, so basically we let the agent to make the actual changes by itself, or in some cases, and you will see a video very soon, it's requiring a human, let's say, approval for a certain change, but it's still a proactive topic. One but not least, we are using GCP technology. So in general, we are in a partnership with the Google Cloud Platform, and we are using their technology for this event itself. So hopefully I will have some voice as well about the Run Guardian agent. So basically, in the short video, we just demonstrated that what the Run Guardian agent can do. So in that actual use case, we have a traffic jam, which is accumulating on the highway. Then you already know that in that segment, there will be a performance degradation because more people, more cars will be in the same site. Then it's actually based on the KPI degradation that we are constantly following. There are recommendations to switch off carrier aggregation, to change some DSS parameters, and even there is one thing that we are not allowing autonomously to tilt the antenna by 2 degrees. So basically, that as well, for which we are asking basically an engineer approval. But in principle, with that, we can see that whether the performance is getting better, and we are able to solve the situation. But of course, this is continuously monitoring itself. So if you see that even there are more degradation or it's going to the wrong direction, then it's basically recommending additional insights and additional recommendations how to go forward. So that was one case from the RAN itself, or the radio access network. The next use case is, we call it Cognition. It's an AI chatbot. The project name was SpexFinder at that time. Why it is a problem? So our problem statement is, everyone is talking about AI, and honestly, we are working with really dozens or even hundreds of vendors, be it Nokia and other ones as well. Everyone is providing different AI agents. Each product has an AI agent, but it doesn't help us because we want one single, basically, AI agent or chatbot with which we are able to communicate all of the specification, all of the design documents, customer documentation, test plans, whatever. So even though, yes, we are getting basically constantly from our vendors that, okay, I have the coolest chatbot, it can manage the, I don't know, one Nokia product, let's say you can get insights from that product, but yeah, we have 4 or 5 different vendors in the same network, so we need one single solution. As well as, of course, there are some topics which are confident, so we are operating, of course, critical network infrastructure. So in some cases, we are not able to upload documentation or configuration files into any public system, but we have to run many things on-prem. And that is very important from privacy perspective, how we are able to do that. Some clear requirements for the SpecFinder topic. Of course, there are some classified documents that we need to protect, be it the configuration and so forth, which is connected to the network. But as well as, I'm not sure if you know, but even Nokia customer documentation is confidential information. So we are not able to just give it to a third party to use it in any other solution, but we can use it on our own premises, on our own system, but we cannot give it to somewhere else. But if we are building such system, we can put Nokia and all of the other competitors document in the same system, so we are able to have a better base. Then, of course, it has to be self-service, of course, as less resources as possible, continuous update, different machine and human training cycle, and last but not least, this is an internal tool. Of course, we want to operate as cheap as possible. And with that solution, we were able to create this Cognition SpecFinder. But if you are an engineer and you know that how detailed are the specification and customer documentations, it's really a game changer that you are able to ask basically that, okay, from this 1,000-page 3GPP specification, please send me that how, I just asked, for example, how, I believe the question was that I was asking that how CSCF and telephony application server is communicating and what interface, whatever. And of course, you can get all of the information, call flows, whatever that needs to be made. But of course, it's more than that. So it is able to answer even to not just to prompts, but you can drop in documents, you can drop in pictures, architecture diagrams, and based on that, you are able to work with. It can generate code. Then, of course, all of the others, this text-to-speech, speech-to-text. By the way, I'm not sure how many of you use, but it's a kind of cool feature that you just switch on your microphone whenever you are working and you talk to your agent. You don't even need to prompt, but you just talk to your agent or talk to your chatbot, and it's able to generate code for you and able to create text, whatever. So it's a kind of cool feature. It's how it's working. So that's the unified chatbot solution, and really that is solving us the problem that we do not have 12 different from the 12 different vendors, but we have one single solution. But how we can improve this even further? So We are working on a so-called observability solution, which is able to manage the whole service chain, again, from the devices until the actual core networks with all of the components included. And of course, we want to use MLOps and AIOps technologies to assess that what is happening. And of course, the best communication way is that we have a chatbot which is able to get the information. Two examples here. Of course, there are much more roles, but the network engineer is able to talk to the network, that, okay, what are the issues with the network, what is the status of the network, and so forth. As well as, of course, a manager might have different questions, but still the same solution would be able to help them. So that's the, let's say, a chatbot solution, what we use AI for. Then the third one, the Open Search, which is basically a log database as well as log analytic platform. It is actually a spin-off of the Elasticsearch. I believe in Nokia you are using that as well. But basically coming to just to have a give background that why it is important and why we do that. In Europe, except Germany, we are basically providing the cloud infrastructure to all of these national operators. So altogether, we have actually at the moment 11 countries where we have. There are some spots which are not even under our possession. So Telekom Romania, we just finalized the closure and the sales of it, but still there are some cloud infrastructure that we use there. But the main point is that NT workloads, so network technology workloads, are basically on this commonly managed network infrastructure. Of course, the problem was with that yeah, in 11 countries, 37 whatever clusters, it was not easy to monitor. So you do not want to have a country-by-country solution, but you have to have a unified solution that how you are maintain and monitor your cloud infrastructure, because you are hosting a critical network infrastructure on top. That is why we have a solution called Clearview, which is basically a unified observability platform and log collection platform, which is providing based on Grafana visualization. But in principle, you can see lots of open source as well as paid solution as well that we use here. Even Data Robot, which is we purchased from Nokia, so that is something which we can route to this company. But from today's presentation perspective, the most important is the Open Search, which is, as said, a log analytics platform and database. And just as a fun fact, today we are just from textual logs, we are actually collecting more than 100 gigabytes per day. These are just textual, so no binary whatever, 100 gigabytes of textual data logs per day, which is kind of a lot, so to process that. Talking about a bit about Open Search capabilities. So primarily, this is something that collecting our logs from the different network functions. Whenever we are talking about structured logs, I would say we're rather straightforward. So if you have a structured log, you can apply rules, and in principle, it's quite easy to manage and correlate later on. But especially in the Kubernetes environment, all of your logs are unstructured. So Kubernetes is pushing you a huge amount of unstructured data into your data lake. And of course, you have to do something with that. And of course, for unstructured logs, yeah, for that rule-based is not an option. You have to have other solution. And what is kind of good with the Open Search, that it has this pattern recognition built in. So basically, it's able to recognize in the log files different patterns based on the data, as well as it has anomaly detection engine built in so that you can use. The other thing, and actually how we are using that at the moment, that you can even use external models for which you are able to connect to, and you can do this clustering based on that. The anomaly detection can be made. So this is how we use that. The actual let's say, way that, so this is just a comparison of the traditional rule-based, as said, for those cases whenever we have structured logs and you have clear thresholds. It can be even a generic time series data that you exactly know that if you reach a certain threshold, then you raise an alarm. For structured logs, this is perfect. You can still use it. But whenever you can imagine, coming back to the previous example, you have from 11 countries, you are dumping in really gigabytes of logs per hour, then definitely you have to use some other solution which is able to scale and able to manage that unstructured data. That's why we were using in this segment the anomaly detection for the OpenSearch logs. It was, by the way, let's say a bottom-up type of project that our team started to work on that without actually, let's say, push them to have this solution in this topic. And I wanted to give some insights that what we have learned, what were the challenges and what we have learned during this challenge. One is that definitely whenever we have built initially, it was used simply CPUs. So we have used different models. It was good for whenever it was, let's say, lower amount of parameters and so forth, it was still okay. But whenever we were able to purchase a data center grade GPU, it's NVIDIA H200, then immediately the performance average we see 10 to 15 times improvement in terms of performance, but in some in some times of data, we even saw 40% increase. So really the learning is that GPU is a must if you want to use it, especially in production, but also for training, it's a big topic to have your own GPUs. As well as, by the way, it's a big learning also for us that for data scientists, you have to, so there are very specific type of laptops you have to purchase because, of course, you do not want to give everyone a H200. By the way, one single server with this is 25K euros, so it's not a cheap one. But of course, for your data scientists, you want to just to tune the parameters. It's better to have it on the laptop, and later on, with bigger data, you are able to train on a GPU. And that actually goes to the second learning that whenever you are working with AI and ML, it's not something which is just solving your issue within a second. It's a lot of, so this whole project was more than three months with continuous parameter tuning. Changing one parameter, yeah, you increased by 1% the accuracy. Changing another, you decrease 1.5%, whatever. So it was really an iterative process through which our engineers and data scientists were able to tune the model, which is reaching that accuracy that we are able to use it in production. And basically, the learning is that exactly that don't be afraid to try out new things and to play with the models. And the third part is that so let's try to work together with other teams. As Gergely said as well in the previous presentation, there might be the same solution in two, three, four, five, whatever teams who are working on the same issue. And exactly we have figured out the same. Either in the central organization as well as in the NotCos, we were able to see that many people were working on the same solution. And that actually led to the situation that, yeah, in principle, we were able to put together data scientists, data engineers, and others, and we were able to build really a production-grade solution. So these were the, let's say, the generic use cases I wanted to share, but still, I have a term that I usually say is this AI for good. That how we are able to augment humans, because I'm a firm believer and exactly what Julia said at the beginning. So it's we need to augment our workforce. It's not going to replace in many cases, of course, our engineers. At least I'm not afraid that it will change the engineers. Other sectors, I would be more afraid, but at least from engineering perspective, I'm not worried about that. But few other cases that we are running. One important proof of concept that we are running is AI-assisted trace analysis and root cause analysis. I don't know how many of you are network engineers or test engineers, or at least have used that. But actually, one of the most time-consuming topic is that you have a PCAP file from the network that you are able to download, and then you open your Wireshark and go through basically the messages line by line. You are opening the message content and see that, okay, what is happening. Now we are working with a company who is able to basically provide the root cause analysis with 95% accuracy, basically in seconds, which was really several hours previously. So we are now actually putting into two countries, and we see that how much we are able to accelerate the work beyond the POC, of course. But this is a big one. Copilot, of course, these Copilot use cases are, I believe, essential. So everyone is now using it. Just a recent learning. We are working with an external company and on one product, and we had no good documentation, basically, to hand over that documentation to the external company. And our engineer basically said that it's 30 story points, so if he's doing that, he will be ready by February. Of course, that's unacceptable. And then with Cloud Code, the same person was able to do it in 1.5 days with 500 pages documentation, with different pictures, architecture diagrams, whatever. So basically, in 1.5 days, we were able to do what's supposed to be 3 months of work for one person. So there is very, very huge potential in using that. But still, that is important that you are still the validator. So you are not, let's say, a coder anymore, but also an orchestrator and validator, because you have to make sure that whatever the system has created is still yours, because still you are responsible. You cannot tell your customer that, okay, I have a network outage because of AI. You have a network outage because you are Telekom, and Telekom is still responsible. So you have to make sure that you are taking that seriously. MLOps, as said, MLOps for anomaly detection, AIOps for RCA, and really this autonomous resolution of the issues. That is also something what we use. Again, MLOps system is coming from Nokia. We are working on different use cases with that. And last but not least, this observability of the telco network operation, really to talk to the network and in the different dashboards to understand that, okay, what is happening in a different service chain. And then to really the agents are able to even heal themselves like the Run Guardian, that if we see a service degradation, that is able to basically react on that and then go forward. So that being said, it was more of summarizing that, okay, what type of use cases you can see in the telco operation, and what telco operator like Deutsche Telekom are facing, and how AI can help. So thank you very much. It was nice to be here, and I'm open for questions.
Thank you, Tamás. Before we go to the first question, I would ask the question of the chair of the day. What is the X factor in AI?
Yeah, the usual question for me is definitely speed. So that, like this last example that I've said, so if we are able to do a job which was really a tedious documentation work for several weeks and months, and that we can do in basically a 1.5 day of tuning, then it's really a game changer. So for me, that if we are able to replace those boring, I would say many times tasks with machine, then definitely it's really a cost saving immediately for us.
Thank you very much. Questions, please raise your hand. There is one.
Okay.
My question is about the EU AI Act. How applicable is it in your case, since there are customers there? And what I'm talking about is not just the data governance, but transparency and robustness aspect of it.
Yeah, let me have my official statement and my personal statement on that. Yeah, we have the EU AI Act, which is very restrictive on how to manage the data, what type of information AI can access to, and of course, what type of, so how you are actually using that data with the AI. So it cannot be harmful for people, it cannot be exposed data from certain people. From, let's say, a citizen perspective, and that's the official answer, this is a very good, let's say, way to protect the data of all of our people. And yeah, basically that's my official answer. My personal answer is that only in Europe we have this EU AI Act. And by the way, we have a data act as well that we have to be basically compliant with, including some which is produced by our products as well. So there are lots of, we just collected, there are something like 12 or 15 different acts at the moment, which is in this area, be it security or this Privacy Act. Personal opinion is that it's very much slowing Europe down compared to Asia and the US, because all of our companies as well as the operators are so much regulated that we have to do additional effort to manage and comply with all of these rules. While if you are a US-based company, you basically just dump the data, you manage it, and we are basically in a competitive disadvantage in this situation. But that was my personal view.
Thank you. Next question. Waiting for the coffee break, I see. Okay, that's, I believe. Thank you very much. Thank you very much, Tamás.
Thank you.